Yes.
Hello everyone, welcome
Hi.
to the live stream. Hi there! Hi Time, hi Ezzy.
Right.
Hi Daptak, hi Jay, hi Tankominos, hi! Hi everyone.
There's some people collected.
Hi Quasar!
Well, what
Hi.
are you all doing?
Yeah, we're just, you know, it's always the community stream, I suppose, in this case. There we go. Feels weird to join in on to stream on a channel with people already in it. Just odd. Don't make this
I'm
roundabout.
just gonna make this. Right, yeah.
Don't make this roundabout miles. Make it. Oh no, it's not gonna be miles. It's moles. You see, that's an important distinction. Today we'll be working on a video, which I think I have motivation for it, so I think I might finish in 2 days. Today we're going to be working on a video specifically made to explain why moles are not a unit. So yeah, it's going to be fun.
I hate you so much.
You know what's even
With a
funnier?
burning passion.
I actually found like the most definitive proof that no one treats moles as a unit, and it's so hilarious. Do you know the ideal gas law?
Yeah.
What I find hilarious is that the ideal gas law does not hold if mole is a unit. You either have the ideal gas law, either the ideal gas law holds or mole is not a unit. You can only have one of these two.
What?
Let me show you.
What?
That's why I'm so happy with this video, because it's great. Okay, so basically, here's the thing. The ideal gas law is ideal gas law. I stumbled upon this fact when I was researching the Boltzmann constant, and you can express the ideal gas law using the Boltzmann constant like so. PV is equal to N K. Wait, was it NKT? NAKT? Where is it?
Yeah.
NKT. Yeah, the whole point here is that you take the pressure volume is equal to an Avogadro's constant, Boltzmann constant, temperature.
There is no A needed there because that's the number of atoms and not Avogadro's number.
Yeah. However, the K comes in there because K is equal to, oh, where is it?
That A is not needed in the equation.
Right, that is N, correct. So this is the number of molecules of a gas. What is the unit of number of molecules of something? Amount of matter, if you will.
Yes.
Moles, exactly. The N is there because this is how many moles of a gas you have. And what I find hilarious is that you have moles on the right in the form of the N, because it tells you, you know, how much, the amount of matter. It tells you the molecules of gas. That's what mole is used for.
Not low. If you wanted to use moles, you'd have to use a small n and an R instead of a K.
Yeah, but then the capital N, what is the unit of capital N?
It's the amount, just not the SI unit, like not mole.
Okay,
but
what is the difference between amount of molecules in moles and amount of molecules not in moles?
What's the difference between distances in kilometers and distances in miles? Just a
Well, same dimension.
measurement.
It is same dimension.
Yeah, it's the same dimension, just a different unit.
No, the unit it stays the same because that's the point of dimensions. You just scale it up or down. So you do agree that in this case you can scale it up or down for it to be the mole. So we could just do PV is equal to X N KT, and then in this case this would be actually X lowercase n KT, and this would work then, right? Just like with kilometers, you can scale them up or down to get them out. Cool. So in this case, we get pressure. We get pressure times volume times moles times Boltzmann constant times temperature. And Boltzmann constant is joules divided by temperature, if I'm not mistaken, which means that if you multiply both these together, you can cancel out the temperature, cancel out the bottom of the Boltzmann, and get just joules, which means moles times joules is equal to this. Pressure times volume, that's a bit more confusing, but it does result in a joule. It does result, which means joule is equal to this, and if you cancel both sides, you get 1 is equal to xn, which means that the dimension of the mole is equal to no dimension at all.
Yeah, but your this doesn't hold because scroll up a bit.
Because what?
Because
Yeah, okay.
I scroll at a bit. I don't see the the x n, the when you change the large n, the capital N to xn, both of them have a different both of them are different units.
Yeah, okay, so how would you describe n in terms of elementary units? How would you describe it? Number of molecules.
Yes, that is just mole over the Avogadro's number.
Mole, wouldn't that be mole squared? Wait, mole
No,
over the...
Mole over the Avogadro's number.
Like this?
Yes.
Hold on. Avogadro's number is mole. Okay, Avogadro's number is 1 divided by mole, which means in this case you would have mole divided by 1 divided by mole, which I may be wrong, but I do believe that's mole squared.
What? No. The Avogadro's number is not 1 divided by mole because Avogadro's number is a constant. It is not a unit, it's a constant. Expressing more, then I'm wrong, then
Which means in this case, that's actually even worse, because in that case, mole squared would be non-dimensional. You're trying so hard to justify the existence of a mole. Trying so hard. At some point, once you start like headbutting into the wall again and again, you have to realize it don't make sense. Every time I do chemistry, math, or homogeneous physics, I get mad about units being per mole. I know, it's idiotic, I know. Dang, moles is like the imperial system, but in America. Moles really are the imperial units of the SI system. Hi, the Reblax, hi. Hold on, I was not invited. No, this is not topology. We already did a math stream yesterday. I'm not going through that again. Also, another thing. Because, damn it, there's actually so much work to do. But it's fine, it's fine. Another thing. Oh yeah, I was rendering. Speed of light. No, that's a solid constant, unlike Avogadro's. My current theory is that when physicists were making up the base SI system, like an inorganic or organic chemist barged into the room and they felt so awkward that they're like, oh yeah, well, no, we totally had a unit for you. It was the mole. It tells you how many things there are. Just, you know, in general, things.
I'm calm. I'm calm. I'm perfectly calm. I'm not annoyed.
In my opinion, moles are useful, but not units. Exactly! Welcome to the party, Alex. Welcome to the resistance.
They're literally defined as a unit by the SI system.
Yeah, and I can define my sandwich as a spaceship, but you know.
Maybe you need to give chemistry just their own glory moment. Let them have their moles.
But the thing, it's not even chemistry, because theoretical chemists have the elementary charge and they're doing fine with it. It's not chemistry, it's just organic and inorganic chemists. They just really wanted a unit. Wouldn't making new dimensions help up with that? Yeah, but then the dimension would have to be equal to no dimensionality at all. which I mean that's kind of pointless. The whole big deal of a dimension is that you can't just have something be without a dimension and a meter at the same time, because you need dimension of a meter. The system is consistent, make it. In one place, you have a mole, which is the amount of... What is it even? Molecules, particles. The amount of stuff. Great definition. And then in another place, you have the amount of stuff, which is not a mole. How is that consistent? That's the opposite of consistency. As a mathematician, I am very familiar with making shit up. Yeah, but as a mathematician, if you defined x to be fucking 5, you can't just close your eyes and write down x is equal to 6. That ain't how consistency works. That's not consistent. Freaking moles.
But we need moles to use SI units efficiently in chemistry.
Yeah, right. Yeah, you need them. You totally need them. You couldn't just say that if we have 6.022 to the power of 10 to the 23rd molecules, then, and just you do it without the moles. I mean, you could do that, but you don't, because I just really feel fancy when you use the unit, I suppose. I was ranting about moles. Sign me up. Always. Mole is not a unit, by the way. Exactly! It is not!
I hate this place.
No, it's just sometimes you attach mole to it and sometimes you don't. It works. Light. So this. There we go. The only
I almost asked why did I even join the stream with this title, but then I realized
you didn't really
you.
join.
Yeah, it was you who actually joined, and I just had a peaceful day, and you just barged in and decided.
Yeah,
to,
how dare this make it join onto their live stream channel when he's live streaming? My goodness. Honestly, no manners whatsoever. Live streaming on their live stream channel that was made for their live streams? Unheard of. Unheard of. When you wrote xn, it doesn't remove the mole unless x is a mole, in which case it makes perfect sense. What I'm saying is that you don't have a constant number, a constant mole. No, here's my point. Here's the thing. N refers to amount of molecules. Now, mole, as a unit, is the amount of matter. I don't remember the definition. It sucks so much my brain refuses to learn it. Mole unit. It was something like amount of matter or stuff like that. Measurement based on the amount of substance. Yeah. Proportional to the number of elementary entities of a substance. So N tells you the number of elementary entities of a substance, and it is not a mole. N tells you the number of elementary entities of a substance, and it is a mole. And so, like, they both refer to just amount of molecules of gas, but like, one of them is a mole because it's lowercase, and the other one isn't because it's uppercase.
Yeah, you're like comparing like miles to kilometers. Like both of them are just units for the same stuff.
No, but the left one doesn't have a unit. That's the big deal. If it has a unit, then the ideal gas law is wrong. Then we need to do an inequality there. So this is not me comparing kilometers to miles. I am comparing kilometers to something that is not a unit.
Okay,
I mean,
I'm gonna just do the math for the gas law myself, because I'm pretty sure it only holds if moles are a unit.
it only holds if moles are a unit and you exclude the n as not being a mole. However, if n isn't a mole, what the fuck is a mole then? If you can't express the number of molecules in a gas as in terms of moles, why do you even have moles? Can you just not use moles for a gas? Is that a law somewhere? That's kind of like saying that we can't use, I don't know, that we can't use meters if the temperature is too high. Like, yeah, it's made of bullshit, but it's consistent. My whole point is that it's inconsistent. And as elementary entity is an n counts packs of elementary entities. What is that? Hold on. Look at this. Look at this stuff. Ideal gas law. Look at this stuff. N is the amount of substance, right? That's mole. But capital N is not amount of substance. It is the number of particles of a gas. So lowercase n tells you how many molecules you have. Uppercase n tells you how many molecules you have. But uppercase is not a mole. Because it wouldn't work if it was a mole. It's the dumbest thing. It's driving me crazy. Elementary entities. Maybe the definition of elementary entities is what. Maybe that's it. Elementary may be known as atom, molecule, or ion. First of all, if you start your definition for depending on the nature of the substance, you're doing a base SI unit. What do you mean? Okay. For example, 10 moles of water, a chemical compound, and 10 moles of mercury, a chemical element, contain equal numbers of substance, with 1 atom of mercury for each molecule of water, despite 2 quantities having different volumes and different masses. Alright, first of all, so unit changes meaning depending on what you talk about. That's exactly why we want units, great. But keep going. The mole corresponds to a given count of entities. Usually the entities are counted as chemically identical or individually distinct. Okay, so a given count of entities, which means, I may be wrong, but if it corresponds to a given count of entities, a count of molecules of a gas should be confined in that, but whatever. Well, why not? Let's exclude it for the sake of, why not? For example, a solution may contain a certain number of dissolved molecules that are more or less independent of each other. However, the constituent entities in a solid are fixed and bound as arrangement, yet they measure without losing their chemical identity. Thus, solid is composed of a certain number of moles of such entities. Yet in other cases, such as diamond, where the entire crystal is essentially a single molecule, the mole is still used to express the number of atoms bound together rather than count of molecules. Thus, common chemical conventions apply to definition. Can you stop bringing in the exceptions into other... Whatever. It's chemistry. Obviously, it says it depends. Reblax, I'm sorry. Okay, would you like chemists to get into math and start putting exceptions everywhere? Would you like that maybe, huh?
I am calm. I am the utmost calm.
Number of molecules and moles should be the same thing. They are the same thing. Give some love to Candela. No one cares about Candela Altimeri. No one does. No, physics and chemistry is that it's an old math and they can go law, it works. Not really. If you have a model in physics, you still want to like... That's not even true. I mean, in theoretical chemistry, you still do it with hypotheses and then you test them. If you want something rigorous that actually works, just do math. I feel like you're taking the worst parts of overgeneralizations in science and you assume that like all of science like that. No, it's just the moles. It's just those people who freaking think that moles are a unit.
I believe that those people are the scientists.
No. Those people, we call them in the actual business, we call them delusional.
Like the scientists define it as for a reason.
No, it's just organic and inorganic chemists. I refuse to believe that any physicist would actually believe in this stuff. You can have a mole of photons, because of course you have. Okay, that's great. A mole of photons. Absolute buffoons. Hold on for a second. Okay, it's a mole of substance. I mean...
we
the entities are
go back to
usually
the-
molecules, atoms, ions, or ion pair specific ion. I like how it's usually because you can use it for everything. There is a mole of photons.
go like just read the next sentence to so you might believe that physicists actually believe in moles.
The obsolete unit Einstein is variously defined as the energy in 1 mole of photons and also as simply 1 mole of photons. The obsolete.
I am not even sure what that Google Translate, please. I didn't know that word.
Oh, it means like not used anymore. Mole is so dumb. Where do we draw the line, by the way? Why should we draw the line? Because, okay, here's the thing. When you have a mole of photons, quantum field theory exists. When you have a mole of photons, wouldn't that be just like the amount of the electromagnetic field? Or rather, the amount of the magnitude, if you will, of the electromagnetic radiation.
I mean, you can translate it to that, but the point of moles is that it concentrates on particles.
There's actually physics have where they say, let the size of matrices go to 0. Size of matrices is going fucking 0. How am I supposed to not believe people behind her? Okay, but like 97% of the time, if you see some random bullshit in maths, it's gonna be due to like organic and inorganic chemists. My favorite example is with metallic bonds, with bands, basically. With bands are my favorite example, where in order for the band theory to work, you have something discrete, and as you add in more ions, you get like basically more and more energy levels. And the basic idea is it's great. You have discrete amount of energy levels, right? You have discrete energy levels. And then the basic idea is as you add in more and more atoms, more and more ions, you get more of them. And basically, the limit as the amount of ions approaches infinity gives you something that's no longer discrete, only gives you like I'll represent it here as like a function, there we go, where these are the bands. And so basically what chemists say is that is not even electric, I think it's electrochemists more exact, is that basically in a metal you have so many ions, you have so many electrons that we might as well assume it's an infinity and we might as well treat them as bands. Like, oh, it's, you know what it is, it's like trillions. That's basically an infinity. Almost always what happens, it's almost always in chemistry, it's hilarious.
Alright, I would like to answer a few things in the chat. First one, are moles even used in chemistry? Yes, I did study chemistry in higher level. Yes, they are useful. And is it moles or moles with E or not E? Like, if it's like mole with an E at the end is like kilometer, and mole without an E is like km, short for kilometer. So that's just basically
Also,
how you denote it.
Tankominos, you asked, are moles even useful in chemistry? Think about it this way. When you have energy, when you express them in electrovolts, and then you switch it to joules, then you can have like a constant here, like a constant that, so C will represent a constant, like a constant that, you know, transitions between the two. And moles are kind of like that constant for switching between the atomic mass unit and kilograms. Now you may notice that I said constant. I did not yet. That was not a mistake. They do function as a constant. Next question.
Yeah, are unit though. The constant is the Avogadro's constant. Moles are units.
That still work as a constant, and I use that as a constant.
But it's a unit. The constant is Avogadro's constant.
Well, if it quacks like a duck, it's a duck, in my personal opinion.
But it doesn't quack like a duck.
No, I mean, you know, it doesn't. If you say that the amount of substance, and the amount of substance isn't the amount of substance, then yeah, it really doesn't. Why isn't this n a mole? I don't understand. Why isn't this a mole?
Why isn't a mile a kilometer?
Well, it is. It's rescaled.
Exactly.
But this
It's
isn't a
rescaled.
rescaled. But this isn't a rescaled mole. So why isn't this a mole? Because if you treat it as a rescaled mole, and as I mentioned, you get this, which is not something you want, because this basically says that mole is a constant. N is a rescaled mole. Well, it can't be a rescaled mole, because if it's a rescaled mole, then that means moles don't have a dimension. Because you get a mole on one side of the equation, you don't get it on the other one. That's the fun bit, you see. Hold on. Let's find an answer. Let's look for an answer. There has to be an answer. There's no way people would just leave that be and say, oh, it works, we shouldn't worry about it. N is the amount of substance. Okay, great. Equation, the most frequent forms are, there we have it, right. N is the amount of substance of a gas, so amount of substance of a gas, which is usually molecules, atoms, ions. They don't specify here if it's number of, but I think it's a gas, amount of gas, so it should be amount of molecules. So N is the amount of molecules of a gas. Now N is the number of particles, usually atoms, molecules of a gas, which you may think it sounds like the same thing, but it doesn't, because one of them refers to the amount of substance, so amount of molecules, and the other one refers to amount of particles, which is molecules. So like, but I don't think there is a rule that says one physical things correspond exactly to a unit. There is, Reblax. That's the whole point of the base SI system. That's the whole point. The whole beauty of it is that if you manipulate units, it holds. So basically, you don't have to think about it. That's always my example. If you have a car traveling at 5 meters per second, and you want to figure out how far it will travel after 4 seconds, right? Then you just multiply them together. And what you get is 5 times 4, that's 20, and you cancel out the s's, you get 20 meters. The units hold. If you want to figure out, I don't know what, actually velocity, that's kind of it, I would need to go with momentum for the fun stuff. But the point is it holds.
Also, Reblox, yes, there is. In quantum mechanics, you define every single possible unit as a matrix on the Hilbert space. That is just every possible unit in physics. If you want to take a look at it from the quantum level, is just an operator on the Hilbert space, an infinite dimensional Hilbert space. Just to.
I'm looking it up. I was not aware because I'm really curious. How does it work for the mole? The problem is not the manipulation. The problem here is that you are saying that physical interpretation of something should mean it is in moles. But I mean, should it not? Like, if you have amount of substance of a gas, so the amount of molecules of a gas, and the amount of particles of a gas, so the amount of molecules of a gas, what is the difference between them? I'm sorry, am I the only crazy person in Sane Town, or am I the only sane person in Crazy Town? What is the difference between capital N and lowercase n? I'm pinging the Discord. I don't know, I need someone who knows thermodynamics.
I guess that'd be ChatGPT for now.
Ah, no, you. I need a trusted source. Why did I turn this off? Actually, what is the difference? Especially with this, I need a trusted source, because if everyone says that they're not the same, but doesn't actually give a reason why they're not the same, I mean, it's made up bullshit, but once you accept that, the units work out. You can't accept that in science because that way you can just make any claim you want. As I mentioned, I can call my hot dog a spaceship, but I'm not gonna sell it to NASA for $1 million just because it's made up bullshit. Again, the mole drama. The mole situation is crazy, okay? They keep dealing with the lowercase n. I want the uppercase. What's the difference between... Oh, uppercase. There we go. Okay. Wait, what? Atomic mass is the average particle mass times the atomic mass constant. Right. So this is just mass divided by mass, and this is just a scalar. That makes sense. Wait, isn't average particle mass the molar mass? Doesn't matter, let's not get into it. Just, whatever. Average particle mass. Dimensionless, makes sense. Lowercase n in moles. N is the amount of molecules in a gas. I'm sorry. If a capital N is the number of molecules in a gas, then what does lowercase n represent? I'm losing my mind. I feel like someone is like, if someone... I mean, Timon, like, beside the argument, can you see why I'm losing my mind? Because to me, it feels like if someone gave me a capital M and lowercase m and said, oh no, lowercase m is meters, capital M is distance, they're a different thing. What do you mean? What's the difference between them? I'm losing my mind. I'm going crazy.
The meter is a unit. Distance is a dimension. And meter is a unit to measure the said dimension. It's different.
Okay,
Like,
so if I have a
distance
distance of 5 and 5 meters, those are different dimensions. Like, you can't just take a distance of 5.
You can't have a distance of 5. You need a distance of 5 meters.
That's kind of my point. Yeah, that's kind of exactly what I'm saying.
But
No, firstly, because it needs to be one single link as a concept of human quantity of money. No, just because two things close to each other means something in the universe fundamental. Yeah, but Reblax, I could make the same argument for math if you want. Like, I could say that. Wait, hold on. Let me think for this for a second. Let me give you an example in mathematics that you could maybe understand. I could say that. Oh, you know what? We should only treat everything as Euclidean space. Because all axioms are made up anyway. We might as well go with the ones that Euclid proposed, for everything. Like, you can, because at the end of the day, math is also made up by humans, but I mean, should we? They are the same, but n is a different way to write it. But Maddie, if they are the same, that means the ideal gas law can't be equal if they are the same. That's the point. The whole point is that they need to be a different thing for the ideal gas law to hold. However, if they are a different thing, then the amount of molecules in a gas and amount of molecules in a gas mean a different thing. And I am losing my mind.
But the thing with Mars is that you can just hello.
Hello.
I made it.
We're arguing about Mars again. So, like.
Alright, it'll be fun.
So, like, if you have meters distance, you can't just you need a unit to define it. And if you have an amount of substance, that is a number of entities you have.
Right.
and you can measure it as moles as a unit.
Okay, so now what is the difference? So if I say the amount of molecules, right?
Yes.
In the ideal gas, we have the ideal gas. I say amount of molecules. What would be the difference between the capital N amount of molecules and lowercase n amount of molecules?
It's one of them is more, the other one is just...
That's kind of because I mean that's kind of like someone asking a question. Okay, so what's the difference between an electron and a photon? And you're replying like, oh yeah, because we call one of them an electron, we call the other one a photon. I mean, there are actual differences between things, right? So for example, when we have a particle, we want to know what that particle is. We have certain defined differences between them to figure out what they are. So you can check if it has mass. Congrats, now you know it's not a photon. You can check it if it has charge. All right, if it has charge, that's not a photon, and so on and so forth. So if I've measured something, if I've measured the amount of molecules in the ideal gas, then did I measure it in moles or did I measure it in capital N, not moles?
It depends. Like you can check it. Like if the number of if the number you measured equals to, well, if you count every single particle one by one and you get the same number as you measured it in the number of particles, like that is it. But if the number you get is not the same as the number of particles, but very neatly translates. It helps you translate stuff to grams. Then you measured moles. Like,
so you figure out. So when you measure something, it depends on if the equation holds what you measured. So, for example, if it just so happens that we were wrong about the ideal gas law, we wouldn't know because we always assume that it's correct. Because
no, that's it's like you asked, how do you know if you measured something in like if you measure something, you preferably know what you are measuring. So
yeah, and I measured the amount of
I
particles, the amount of molecules. Sorry, the amount of molecules. What I measured.
Okay, do you measure the amount of molecules or the number of molecules? The number of molecules or
What's the difference between them?
The amount of substance is mole. The number
yeah, but
of
no,
something,
physically. What's the difference
one by one.
between measuring the amount of substance and the amount of molecules? What's the difference?
What's the difference between measuring something in meters or miles?
There is no difference. You measure it the same way. You check the length.
Then, yes. You check, yes, exactly.
Timon, I think what you're struggling to understand here is that miles and kilometers have the same dimension. The amount of substance and the amount of particles cannot have the same dimension. Because otherwise the ideal gas law wouldn't hold. Yeah. If I get some gas, if I count every single molecule in it, how would I know if I've measured moles or not moles? How would I know if I measured lowercase n or capital N?
Like, if you count every single molecule one by one, that is the number of molecules. That is not mole.
Yeah, but is it the amount of substance number of molecules or is it the amount of particles number of molecules? Because both of them can mean the amount of molecules. Like
the number of something and
amount of substance. The entities are usually molecules. That's for the mole. So for mole, entities are usually molecules. However, when it comes to the ideal gas law, capital N is still just particles, which a number of particles, usually atoms or molecules. So if I counted all the molecules, did I measure the number of particles, usually molecules, or the amount of substance, usually molecules? This is actually comical. They both say usually molecules, so I'm glad that they use the exact same language.
Yes, because they're usually molecules. Like, you count molecules and not fucking turtles or something.
Yeah, but I mean, I can't measure both at the same time, so which one did I measure?
It depends. Did you count them one by one, or are you measuring the amount? Like if you start, like it's like, do I have the meter rod or an inch rod in my head? I don't know. Look at.
Timon, but they have a different dimension. It's not a meter rod or a inch rod. It's a question of, is it a meter rod or a second rod? Because they have a different dimension. You can't just bring up inches and meters because, as I mentioned, they have the same dimension. These two do not. So stop bringing up the imperial and SI, because that doesn't work.
Check if you have a meter rod or a stopwatch in your head. I believe that you can. You're smart enough to know the difference between a meter rod and a stopwatch.
Yeah, so when it comes to time and distance, I can tell. I can't tell here, though, that's what I'm asking. If I count the amount of molecules, what did I measure?
Like, the amount of molecules is moles. The number of molecules is the number of molecules.
The amount of molecules is moles, the number of molecules is not moles.
If you count every single molecule one by one, that is the number of molecules. If you measure the mole, then if you measure the amount of substance, that has a unit of mole. You measure it in moles. Moles are the unit for amount of substance. Number of particles and amount of substance are strongly related, but not the same. In fact, the number that is different, the difference between them is like a gigantic number.
What do you mean number between them is gigantic number? Doesn't mole just mean the amount? Okay, so if you have, right, a mole of water.
Yes.
Doesn't that tell you just the number of water molecules?
You can certainly use it to calculate the number of water molecules.
So it doesn't tell you the number of water molecules?
Well, no, but if you multiply it with Avogadro's number, you get the number of molecules.
Wait, what? Avogadro's number, that's in inverse of a mole, so Avogadro's number mole is really small. The mole is an inverse of the number of molecules? Wait, hold on. So if you multiply it, you get the number. So if you take the amount of something, you multiply it by an inverse of that amount, you get the number of that thing. So the amount would be an inverse. Why do you multiply it by something to get the inverse? Hold on, what? I need to write this down because I've got confused. So if I have like 1 mole of water, then Avogadro's constant is defined number of concentrated particles per mole. So that's the number of particles per mole. So you get number of particles if you multiply it together. That checks out. So then mole is the inverse of that. So so if Avogadro is the number of constituted particles per mole, you take an inverse, and that's the number of constituted particles times mole? Wait a second. Avogadro's number, that's the number of... So Avogadro is equal to number of particles per mole. What's mole then?
Amount of substance.
Yeah, but if you have a number of particles per amount of substance, so what's the amount then? Like, because I get what distance is, right? I get what time is, I get what charge is. The amount in this case.
Okay, like it's like I think you can like kind of look at it as, for example, the Planck length, the shortest distance in the universe, is just a
Yeah, no. I get what distance is. That's
quanta.
why I understand what the shortest distance is. In this case, I don't understand the amount. Like
the smallest amount is one particle. It's like the equivalent to Planck length in meters, and then you have the unit, which is mole or
yeah,
meter
but
or
hold
whatever,
on.
which is
If the smallest amount is
comprehensible.
one particle, then what is two particles like just two amounts? If the smallest amount you can have is one particle, then could one particle be like the elementary unit of a mole? As the just like you can have Planck's length and so on, Planck's time, like the smallest unit of time and distance. Could one particle just be the smallest unit of a mole?
Exactly.
Okay. And you see, that's here was where you lose me, because what is the difference between the amount of something and the number of that thing again?
Because if you wanna, if you wanna count every single particle one by one, you get insanely large numbers that you don't want. This is why you don't measure the distance between I don't know two cities in a number of Planck lengths, but in kilometers.
Timon, you keep bringing up like scale values. We're talking about dimensionality, okay? So don't stop saying specific. Stop saying specific units for distance. Just say distance unit, because it doesn't matter what distance unit. Just a distance unit. That's because we're talking about dimensionality. We don't care about the we don't care if it's inches, meters, Planck lengths, kilometers, light years, whatever. Just distance unit. So now, with that in mind, could you repeat an explanation of what's the difference between number of particles and amount of substance?
Sure, like you can have you have the Planck length or the.
Stop saying specific ones, because I was once again we just care about dimensionality.
I'm not gonna say meters or anything. So
okay, then do keep going.
You have an elementary basic smallest possible anything like Planck length, Planck time, Planck.
Okay.
One particle, stuff like that. But these are so insanely small that in a human scale, neither of them, none of those are useful. So we made up units to define these dimensions in magnitudes that are useful in human scales and are comprehensible for humans.
And that's the difference between the number of molecules and the amount of substance?
Yes.
But then wouldn't they mean that they have the same dimension? Because if you take the Planck length, I don't remember what's the symbol for Planck length, so I'm just going to do a D for distance. If you take Planck's length, if you multiply it by, well, however many, a trillion or whatever, just 10 to the 30th power or something, like you still get a unit of length. You have length on the left side and you get length on the right side. So if you take the number of particles, if you multiply it by something, if that's 6.022 times 10 to the 23 or whatever, if you multiply it by something, you will still get the same dimension on the other side. So wouldn't that mean that both Avogadro's and the number of particles, actually this in the case, would it be Avogadro because it said amount of substance, so it would be mole, which means that in this case mole and the number of particles would have the same dimension.
I did not dig this deep into neither of those topics. But I am doing it now. I'm scrolling Wikipedia right now.
Avogadro's content isn't a unit, it's a value. You can 12 bananas, 1 dozen. That's kind of what I'm getting at, Vishesh, but there's a possibility I'm misunderstanding it. 1 mole is just Avogadro's constant, and X moles is just X times Avogadro's constant. No, 1 mole is an inverse of Avogadro's constant. Mole isn't a unit, it's just a number. Vishesh is kind of like my catchphrase at this point, so...
But it's not a number. Like Avogadro's number is number. Mole is a unit.
So this is the amount of substance. Okay, this has a whole separate. Let's just go for the amount of substance. So the amount of substance is in a given sample of matter is defined as the ratio between the number of elementary entities and the Avogadro's constant. And then the Avogadro's constant is defined as the ratio between the amount of substance and the number of entities. Okay, the entities are usually molecules, atoms, ions, or okay. The particular substance sample may be specified using a subscript. No, nature of particles maybe. For a nature of particles should be defined. No, don't derive quantities. No, just like example. What is it? As the amount of substance to a gram as a consequence, the mass of 1 mole of chemical compound in grams is numerically equal to the mass of 1 molecule of formula in compound daltons. Molar mass of the amount of substance in 12 grams. What is the amount of substance? What is the amount of substance? Also, I may be wrong, but N is the amount of substance of gas, and N is the amount of particles. But they're different. Okay, amount of substance, SI unit, nis.gov. Please. Measurement of the number of specified elementary. Fucking, you can't say that because it's not clearly. N, okay, the amount of substance, symbol N, of a system is a measure of the number of specified elementary entities. Timon, they said it's a number of entities. I'm losing my mind.
Yes.
So...
I don't know why.
But that's NIST.gov. That's not even Wikipedia. That's NIST.fucking.gov. I am losing my mind.
Can you either send me the link or just move the day 722?
I can send you, but it's NIST.gov. Why is Facebook there? Here's the version right now. Mali, I feel insane. I'm going so crazy. I am going so crazy because here's the thing. The amount of substance, symbol N, of a system is a measure of the number of specified elementary entities. So if you have a gas, if you count up all of the molecules, you get the amount of that substance because you just measured the number of those molecules. You specified them as molecules, you measure them. So you get it in moles. However, if you do the same thing, that also is the number of particles because that's literally what it is. The number of molecules, which is not in moles. We live in the Matrix. There's no way. The elementary answers must be specified and maybe... Okay, this is... I am going mad. This is going insane. Batman, you see, when you measure the amount of molecules in a gas and call it the amount of substance, no one bats an eye. But when you do the same thing and call it the number of molecules, the society calls you mad.
The villain in this call would be Joker.
I mean, I guess I would be, because I mean, I feel insane. I feel just insane. Like, am I crazy? Oh,
But if you're Joker and I'm your opponent, that means I'm Batman. Hell yeah.
Or, I mean, or you could be
Well, I mean,
Harvey
you do
Dent.
look like a bat, so yeah.
Oh, I mean, to be fair, you are a Batman, like, literally. You're literally Batman.
True that.
What thinking about Moss does to a motherfucker. Like, really, honestly, no other unit ever shook me this much. Even Candela. Okay, Candela has this amazing ability where the more you read about it, the more, like, it blurs away from your mind. So I guess that's it. It's like a memory hazard sort of thing. But no other unit ever confused me as much as this. I am... Hyder Daptak, I'm losing my mind. So we have lowercase n, which is the amount of substance, which is the number of molecules, and capital N, which is the number of particles, which is the number of molecules. Am I the insane one here?
Yes.
But Timon, I just wanna get something. Okay, first of all, Timon, do you understand why lowercase n cannot have the same dimension as uppercase n? I'm gonna write it down in as clear of math terms as possible. Like, do you realize why this equation cannot hold? Like, if it, like, do you realize that, right? Because if this equation does hold, then the ideal gas law shows that mole isn't the unit. Do you realize why this equation doesn't hold?
I'm not sure.
It's because right here in the ideal gas law, right? If you use the lowercase n, you need to cancel it out with the gas constant. So you need to cancel out the moles. If you use the capital N, you don't do that. So the capital N cannot be a mole, because otherwise you would lose a mole.
You merge the capital N in. You merge the units back into R and KB. Like R and KB.
Okay,
have
let me express that in. Let me actually do that in step by step, because maybe that would probably help. So we have NRT is equal to NKT, right? Just this one is equal to this one. Now express it in terms of units. So 1 divided by... can I use MO for the mole, because for the sake of mole, whatever. 1 divided by mole, that's the N. Now R is the gas constant, which is J divided by K. Wait, divided by mole? What? Then you will get mole squared. I'm sorry.
But N isn't 1 over mole, it's N is mole.
Oh no, oh, N is mole. Yeah, right, okay. Thank you. That would have been a big mistake. So, J divided by K mole. And then T is just T.
Yes.
Then this is equal to...
Yes.
This is equal to... And then N is nothing, that's just the 1.
Well, T is in, then be consistent, and T is in K, Kelvin.
Okay, capital K, Kelvin. Then in that case, N is a 1, it's nothing. Then the Boltzmann constant is joules per Kelvin, if I'm not mistaken. Yeah, okay. Boltzmann constant is joules per Kelvin. And T is just Kelvin, right? Do you agree with everything so far?
Yes.
Okay, that's good, because that makes sense. You cancel out the 2 moles, you cancel out the 2 kelvins, you cancel out the 2 kelvins, and what you left with is J equals J.
Yeah.
Now, yeah, because it's the ideal gas law, it has to hold. Now, the important part here is that, as you can see, we switch from N to mole, and we switch from N to 1. So I have written it down, but the really important thing is that I ignored all the constants. all I did is just the dimensions. That's why what this equation basically states. Well, I lost the equation I just wrote now. Okay, there we go. What this equation basically states is that the dimensionality of lowercase n is different from the dimensionality of capital N, because the lowercase n is a mole and the capital N is a 1. Right here, I just divide them by the magnitude to, to leave all the bullshit out. So, kilometers divided by the magnitude of the kilometer.
Yeah.
Okay, so you agree with these two, right?
Yes.
Their dimensions have to be... Okay, so based on the ideal gas law, we know that their dimensions have to be different. Now, lowercase n...
Yeah, lowercase n has a dimension and...
capital N doesn't.
And capital N doesn't.
Exactly.
Yes.
Now, let's... So basically, what the dimension means, it basically means that they're measuring different things. Because if it has the same dimension, you're measuring the same thing. That's kind of the whole point of units. So they mean different things. Now, what is capital N? Capital N is the number of molecules. In this case, it's molecules because we're dealing with a gas. It's not atoms, unless I guess you're doing, noble gases. But in that case, let's treat them as molecules to generalize. Capital N is the number of molecules, right?
Yes.
The lowercase n is the amount of substance, which is the number of specified elementary entities. In this case, once again, we're measuring molecules of a gas, so number of molecules.
Yes.
In what universe, how, and this is a genuine question, how can a number of molecules not be equal to a number of molecules?
I can give you a very similar example. It's like degrees and radians. Like radians are unitless.
No, because
unit.
that's not quite, because if you have degrees and radians, right?
Yeah.
This holds for them. This is equal. If you take like 90 degrees, you get what I'm saying. If you divide them by their magnitude, you get the exact same thing. That's kind of the whole point. So they are completely dimensionless. So I guess it wouldn't be. So I guess it could not work, but simply because they're not in the base SI system.
Yeah, but it doesn't work because radian is dimensionless and degrees is a dimension.
Wait, degrees is not dimension. I mean,
it's not an SI unit, but it is a unit, just not SI unit, because if you use the SI system, you use radians, which is dimensionless.
But they both measure the same thing.
Yes.
So how can one of them be dimensionless, the other one have dimension?
Because we define degrees as a dimension. Like,
did we do? Wait.
Someone's agreeing with me in the chat, so I must be right. But there are random people online agreeing with me, so.
Okay, it is the unit. Radian is a unit of angle. It is not dimensionless. In the SI. Unless.
Okay,
no, it is
dimensionless.
dimensionless. Okay, it is dimensionless. Okay, so radian is dimensionless. Yes. Now degrees. Degrees of freedom. That's not quite what I'm looking for. Degree angle. Can we have a? This is a non-SI accepted unit, and to convert it to radians, you do not multiply it by a constant that has a dimension. You multiply it by a dimensionless constant. So it's dimensionless unit times the dimension constant that gives you a dimensionless. So not only is it not SI accepted, it is also dimensionless.
Yeah, I know it's not SI accepted, but.
So in this case, how can a number of molecules have a different dimension from a number of molecules?
Hold on,
I am going crazy. I have a mannequin behind me, and like I'm about to just turn around and even ask Susie just the same question. I am a hair away from just going outside and just bugging random people on the street, just asking how, just this with a whiteboard. Just, I'm desperate for an answer. Is the mole round again?
Do it!
The whole live stream is a mole round, Lemon. I'm fine. Flame is gonna join in later, and I'm gonna ask the same thing. Because I mean, but okay, but can you see why this is bugging me so much? Because here's the thing. This is just straight up correct. This equation down here at the bottom, it just straight up has to be correct. And that's not me saying it, that's the ideal gas law and NIST fucking gov. I'm fine. In the coffee. I'm out of coffee. Nothing. Okay, doesn't matter. That's fine. Whatever. It's fine. It's fine. It's fine. It's fine. Shout out to NIST, where I read boring cybersecurity policies. But like, I'm going crazy here. Because only one of these two things is possible. Either the ideal gas law is correct, or number of molecules is a different thing from a number of molecules. And like, I am all in favor of the ideal gas law being correct. But the number of molecules certainly to me seems like the number of molecules. They certainly sound similar. I'm fine. Just need. It's fine. It's all good. It's okay. We just need to. It's fine. Whatever. It's all good. I'm just gonna make a video about this, and someone's gonna watch it, and they're gonna leave a comment explaining it all. Moles are really pushing me over the edge. I genuinely will just make a video about this and pray that there's gonna be some kind of I don't know, because at this point I don't even need a chemist. This is like, I would need someone, oh my goodness, thermodynamics, someone who is doing thermodynamics would be perfect, because, but even then, what's the difference between number of molecules? Maybe it's the fact that one of them is amount of molecules in the concept of matter, and the other one is number of molecules in relation to, in the concept of elementary entities. But like, how can you fucking treat the number of molecules differently? If you have 1 million molecules of hydrogen gas, then there's gonna be 1 million molecules of hydrogen gas. How can you slice that differently? Is it all a lie? Is it just one big conspiracy made by scientists to sell us more science? Is big carbon real? What if British people existed? I am fine. Whatever. It's okay. It's okay.
I just love the contrast that the more we argue, the more calm I get, because it's just over time it's just getting older and older, and I'm getting disinterested, and you just get more and more annoyed and just go bananas.
Diamond, I can't let things go. I
get bored of stuff after a while because ADHD, or I don't know.
Like, the thing
I
is,
just get bored of an argument after a while.
The thing is, what upsets so much is that, as I mentioned, there are two kinds of questions, right? There are the subjective and there are the scientific ones. And because the scientific ones, you cannot have a disagreement. There has to be an answer. And in this case,
I know that there has to be an answer, but if I just look for it for a long time without getting any closer, I just start getting disinterested because I don't feel like stuff is going anywhere. So I just slowly lose.
I wanna hear make it recite. It's a meme, Batman. You see, because they're both really attractive when you wanna play with them both, but you can only have one. Are you a furry? No, Batman. You see, I say that space-time in relation to meters and seconds is the best possible unit you can have. Society shows me moles. I'm telling them it's not a unit, and all of a sudden, society calls me crazy. Livestream circa 2025 man unraveling the moles. I mean, let's be real. It's not even the first time I'm going insane. At this point, it's just a make it Tuesday. And make it Tuesday on a Sunday is just the make it Tuesday moment, but I have more PTSD now. It doesn't make sense, does it? Like that's what's so dumb about it. It's usually the more in depth you get into something, the more sense it makes. Like I don't know, unsandy principle, or actually no, the particles as a wave function, right? Like when you first hear about it, it doesn't make sense. But the more in depth you go, the more you realize that particle actually means something different than you think, that the wave function has a serious justification, that the model works, and so on and so forth. And at the end, you get it. With moles, the further you get into it, the less sense it makes. You say peacock and nobody bats an eye. But you say poopcock and society goes crazy. I'm fine. It's all right. I'm good. I'm doing fine. I'm just gonna make the video. I'm gonna explain the pickle I have, and someone's gonna comment in the comments, and they're gonna clear it all up, and they're gonna be like, yeah, make it. The number of molecules is different from the number of molecules because I don't know. I can't think of an answer, but there has to be an answer. There's no way. There is no way mole was just added into the base SI system without anyone realizing that's actually not a unit. There is no way. So yeah, it's fine. It's fine.
Once you're done with the video, I'm gonna share it with a bunch of chemistry people who are smarter than me.
Please do. Please do. Although, as I mentioned, in this case, it should be more people who are from thermodynamics than chemistry, because the ideal gas law is kind of the main thing right now. Like, I just don't understand how can an ideal gas law not say that SI unit was made by a French, remember? That is true. There's no physicist who makes it up, right? No, but the physicist units are great, except for Candela. I don't know what Candela is. No one cares about Candela. So the other physicist units are great. You have the space-time of meters and seconds. You have the division between space and time, because at low energies they act way differently. You have the elementary charge for the charge for electromagnetism. You have the temperature. Simply because you still need the concept of entropy. So that's lovely. You have all of these lovely things, and then I'm fine. I'm doing fine. I'm alright. Planks for mass. I almost forgot about that one. CGS. What's a CGS system? Centimeter, gram, second system of units. I'm sorry, what? That sounds even worse. What about charge? That's only for... But that's only for mechanical system. What about charge?
Well,
Can we just appreciate for a second that we don't have a unit for color charge as well? Like, I mean, we just don't have a unit for that. Whatever, who cares? I don't care. I certainly don't care. Wave number. Why is wave number so late? I don't know. I don't care. I don't care. Actually, you know what? I don't care. I'm fine. Is there a make it AI made by you or your team? No. What do you mean a make it AI? What do you mean by a make it AI? And what do you mean by my team? Gemma. This is not like a research institute where we just, make science. A group of renegade scientists.
A renegade scientist. That sounds so badass.
Yeah, that's the dream right there. Okay, give me an NFT. The Make It Foundation. I've always wanted to have like a Kingsman kind secret organization.
Yes.
My goodness. That is needed. We'll get there one day. We're gonna get there.
Well, you already have a bunch of interns, so
Wait, thermodynamics is based on a law that measures things in moles, I think. Oh, you mean the ideal gas law? Don't wanna go that way. No. For what video is this stream? Base SI units and constants video. The Make It Foundation where we make it make sense. Exactly. By the way, I had to switch to live chat because he didn't remind me, Timon. Shame on you.
yep, it's my fault.
Jimmy followed the code inside the land of the free. Put your hand inside the cookie jar, the more than you need. X's example is exaggerated version of me, and here's a version of him, there's a version of he, and it's a version of you. There's no escaping the blame. The way we live is parasitic. Fuck the money and fame. Cut the music. This is entertainment. This is real life. The way we live is lunacy. Community, it declines. We're hyperpolarized. We're always fighting and we divide. Truth is important than the money that we designed. Truth is an invention. Politics from inventions. They all come from people's ideas. Did I mention law is an invention? Law and border fuel detention. Border is an invention. Law and order fuel detention. That leads to people killing each other. My solution is everything is subject to change. We could build utopia of individuals who are taught to use their brains. If we teach kids at school to always be sheep and put themselves before the head, and if there is more money for me, then there is no future I see in which the humans survive. Parasite inside the petri dish of camel minds. More grow up on the surface and consume till it dies. And our fate will be the same without the story to the wise. That's the part of the I think Money Game Part 3, if I do remember correctly, that doesn't even have any music. It just goes so hard that it's great. Make it AI. What is make it AI? Look at that now. AI. I'm assuming they misspelled make it because they're a bunch of dum-dums. There's make it AI, make it AI. Why make it? What a question. Copilot to create your unique AI. Try make it. Innovators that empower both individual businesses to harness full potential via technology could be explained. Oh, buzzwords. That's nice. Oh, they're not gonna last a whole lot. Ooh, that's illegal. Oh, okay. Well, you know what, Gemma, there is an make it AI, but it's not gonna be there for long. So, don't worry. It's not gonna be there for long.
What did they do?
They basically, there was like one of them is using it as a law assistant, which there were already two different companies which both got sued out of existence for providing law services with AI, simply because in order to be an actual law assistant or a law, I think there's a different term for it, but it doesn't matter. Basically, you need a license. You need, bar exists for a reason. Must pass the bar, exactly. And so basically, there were only two companies who got sued out of existence for it. So now I guess there's going to be a third one. Sue them? Sue for what? They just use the word make it. I'm not gonna sue for that. I ain't famous enough. Oh hope not for much longer. So do I. I mean, to be fair, we are growing. It is growing quickly, isn't it? A year ago, I had 500 subs. Now I have 50,000. And not a single dom still. Saul Goodman AI. There really were just 2 companies like that who... At least 2. There might have been more. There's only 2 I've heard of. It's funny.
And your most recent video is performing really well.
Yeah, I did say that it was going to perform well. And I was correct, because I'm always correct. Oh, what was that? Here we go. Let's see. 16,000, that is well. That's better than the elementary particles one, but worse than the constants. Oh, someone commented, light is waves in the electromagnetic field, but I thought they were their own elementary particle. I mean... How can you... You're right, you're correct. That's exactly how we are covering, even though he's on minimum wage, exactly you keep it on. I mean, yeah, I don't have enough money to copyright make it. I know if anyone here ever tried to copyright something. It's interesting. Wait, why is that? Uh-oh. Don't tell me you looped the freaking... You did, didn't you? Of course you did. That's great. 2 29. Of course, this one. I have to re-render it again. Nope, I mean timeline. Simple copyright name. Gemma, do you know how much a copyright costs if you want to have a global copyright? I would just like to mention that if you want to copyright it, you do need to specify which country you're copywriting in. So if I would like to do it, I would need to copyright it in Europe, in America, and then all the other countries. I think there exists like 1 or 2 extra ones. It is surprisingly expensive. What's more, Make It already is copyrighted in a bunch of places. You do need to specify the use, of course. Copyright, how about paste left? Checkmate liberal. Europe isn't a country. I don't know, I'm a European nationalist. Someone described me like that like a couple months ago on stream, and it's just hilarious to me to this day. The cost of an application online is $350 for a single business name. Exactly. Besides, I don't need a copyright. The thing is, yeah, other people can like do stuff with the name Make It, but you cannot sue me if you do that sort of thing. So, for example, the Make It AI cannot sue me for having the name Make It, simply because copyright is like the official sign, but you don't need it to be official. Copyright is to make things easier in court, but if all I would have to do is just show that I've been using the name Make It for 5 years now. You can trademark it, yeah. As I mentioned, I don't need to trademark it because I simply cannot be sued for being called Make It. And what's more, if someone ever does claim to be associated with me, I can sue them if they're not, without needing a trademark. And because I live in Europe, it's even easier. Copyright law is already shit. I don't think so. I think it's pretty valid. And then, wait, which part are you talking about? Because there are certain criticisms to the copyright law, but which ones are you talking about from me? Copyright shit is already law. Costs $100 in the US alone, which is more than lighter, even a fancy chemistry one. Ethanol is cheap. Yeah, you see, you know the thing about gasoline and explosives. They're cheap. I don't remember which Dark Knight was it, but yeah. It wasn't the Rising one, it was the one before that. A Benson burner.
People mentioned lighters so much, and I have this urge to buy a lighter so I can light fire whenever I want. But I also don't want people to think that I smoke because I don't, and that is why I don't buy a lighter.
Jeez. Timon, you let us. You see, that's why I think that you believe most the unit so much, because you let society tell you what's what. If people think of you that if you're worried, no, you can't let society. You can't let the haters get to you. Don't let society tell you how to live your life. Buy a lighter. Hell, buy a blowtorch.
I will. Okay. You convinced me. You convinced me. I will.
That's all it took.
I mean, you're kind of good at persuasion, so and convincing people and stuff. I don't know if you noticed.
Yeah, I'm literally Crowley. always. That's like a gayer version of saying I'm literally Ryan Gosling.
I like that. I like that, and I might use that.
Hi, the Markshit. Hi, welcome.
Oh, hello, hi.
Timon Vezimak again. You know, Megatron is right there right now. Abusive parents.
What do you mean abusive parents? Like, like who is the who is the child in this situation?
Well, I'm assuming the muted Itty. I would assume that's the joke. Itty, it's not you. It's not you, but I need to disagree with Timon on moles. Okay, it's not your fault. It just happens. Make it plus positron equals Megatron.
That's it. It is our adopted child now, and has no saying in it.
That's illegal. No,
I don't think actually children have a saying on, like, do children have a saying on being adopted?
Actually, I think you might be right. That's messed up. My goodness. Oh, that is awful. No matter, like, children either have a say or they don't, and woof. I don't want to think about that.
We just touched into a very dark territory.
Yeah, that is really dark. That is really. Oh no. The relative velocity changes things. For example, it changes the move flatter, time move slower, and you need more energy. Okay. Make it. Do you think children are conscious? No, not really. I don't think, and I don't think consciousness exists. I think it's a myth. I think people are just delusional.
I actually agree with that. Like, consciousness is just people trying to justify that the electric fed goo thingy in their heads is more special.
Yeah, like I think therefore I am, but yeah. I mean, I think therefore I am, but do you really? Do you have any proof of that? Didn't think so. Yeah. I don't know what is more abusive: making shitting on a child about moles or being half Hungarian. What do you mean shitting on a child? Who's the child I'm shitting on in this case? Do elaborate. Go on. I just feel
make
like
it is half Hungarian. Our child is half Hungarian because I'm Hungarian and make it is. Oh my god, being half Hungarian and half Polish must be such a torture. I don't want to
oh
imagine
no,
how,
that's
what would be.
awful. That is awful.
Oof.
If consciousness is not real, what gives you more right than animal or rock? Gemma, you do realize that you're talking to a guy who has a mannequin behind him that he talks to, right? So if you wanna tell me that just because something isn't alive, you shouldn't respect it, I don't know if you're gonna convince me of that much. I talk to a mannequin. I like consult with a mannequin.
Also, I'm like animals also have the same level of consciousness as people. I don't know if like consciousness even exists, but I'm pretty sure that a dog is just as a creature that can think as a human. Like, come on, animals are alive too.
Are they? I don't know. I would need some peer-reviewed research on this. Imagine your parents being racist towards you. I'd rather not. Are we calling time in the mannequin? No, I have Susie behind me. I have a genuine mannequin, Gemma. This is like a genuine. It's called Susie. Okay, the motion player is really nice in this. He personifies a mannequin. I don't really. I still call it it. Because it isn't it. That's kind of my big trick for winning an argument with Susie. Whenever Susie, gets, like, is close to winning an argument, I just say, yeah, but, like, you're not real, and then drop a mic, because, I mean... So I should be the only one to have rights. You know what? I think consciousness is just a myth by Big Carbon to sell more life. That's what I think. This is actually so unfair. Like, Big Carbon uses the fact that it's a monopoly to completely demolish Big Silicon. And I mean, what the heck? Where are the antitrust laws when you need them? But whatever. Make it. Yeah, Leben. That is me. That's my name.
Also, Megan, I just want you to know that today I drank my latte with 4 shots of espresso.
Not 6? No, timing.
One day I will.
Magnetism is a bivector, apparently. Yeah, that's why we do the spinning arrow when we represent magnetism so often. Time action. Oh, Lemon, fun fact. Last stream when Reblax joined in, we actually got to... what was the name of it? Parallelotype? Close enough. And there's like a way to generalize the volume, which is just the outer products. And I mean, yeah. Should we also explain these? Magnitude of high dimensional motive.
I'm used to drinking my coffee with just 2 shots of espresso and drinking more coffees a day, but I figured that it's cheaper to get all of it at once. So yeah, now I'm. If one day I'm gonna be really tired and I really need it, I think I think it's a possibility that I will ask it with 6.
That's actually
4 was already something that the barista was looking at me weird, so just so shocked that ask twice if I was sure about it.
You know what I realized recently?
Hmm?
Like with the whole secret, having a foundation must be so nice. Can you imagine, like, okay, so when there was all the revolutions happening in Europe, communists, they had like a bunch of these, like, say what you want about communists, right? But they had like a bunch of different either what they called foundations or clubs or whatever, where they would just all meet up and talk about communism, have coffee. Like, why don't we have that sort of thing nowadays, where you can just, not even with politics or with whatever, where you can just have a place where you're trying to, I don't know, do more physics, and instead of just doing more physics at a research facility, you just all meet up as a bunch of physicists, just have some coffee, you know, plan some experiments, you know, this guy's idea. Why can't we have that nowadays? Industrial revolution is consequences been disastrous for the mankind, you know, honestly.
That sounds fun. Like, I mean, I do go to like, we do hang out at uni with friends, and
But that's
I do go
universities,
to,
you know.
places where physicists go, but none of those are those real core like clubhouses, or I don't know.
Yeah, like, I don't know, just
Oh god, now I want it to be on
building,
the top
yeah.
of a gigantic tree.
I don't know, building a spaceship club, something like that. Can you imagine? Just a bunch of people come together just to build a spaceship, and that's it. I need that kind of thing. Where do you recruit people for this kind of thing? Because I could do it right here, except you live in fucking Hungary. I'm not gonna go there.
I don't
That's
care.
garbage.
I've already checked the train tickets, because I'm I can travel twice a month to Poland.
Exactly twice a month.
I've already calculated it.
I would need, like, I don't know, twice a week at least.
Twice a week.
Build a spaceship club. Come on.
Okay, I definitely can't afford travel. Okay, but wait, there might be like like, there's what do you call that in English? Season ticket, yes.
They're still really expensive though. Season tickets, I mean, they certainly are good if you travel all the time, but if you think about traveling all the time, then they're not gonna make it much cheaper for you. It's...
Yeah, I mean, I like, do love, like, there's already a season ticket for, I already like I already have a season ticket for entire Hungary, so, but like, the entire Hungary season ticket is just insanely cheap for students, because
I sometimes forget you're a student. That actually, yeah, okay, that tracks. I genuinely just, yeah, for students it might be way cheaper.
Yeah,
I should go to a
it,
university just to get discounts, honestly.
then don't go to a university, go to a technician school, and then it's way less work than the university, and you get the...
Yeah, well, the university you can also get drunk with people. It would just be so weird, just you know, this oldest guy going in to the university. It makes you dependent after your body adapts to it. You'll need more and more to get the same feeling. Yeah, but that's the downside of all good things. So this will be length. And this will be
Why
length.
isn't Hungary on an option in the Hungarian railway website? It's literally the website of the Hungarian railway, and Hungary is not a fucking option. What?
Time in. Who in the right mind living in Hungary would ever want to travel to Hungary? Okay.
Alright.
Yeah. The reason why people use tickets in Hungary is to get out of Hungary.
Okay, so, okay. Poland is category F, and Oh my god, it includes like so much more things. Like it includes Slovakia, Croatia, hell yeah.
Is there a single non-Slavic one? Or
Like,
rather not Eastern?
I'm just gonna
Because then it's
send
not
you-
much.
I'm just gonna send you this entire thing.
Not all good things are like that. Have you tried beer? Gemma, what about alcoholism? F. Oh, I mean, okay, it is a lot, but I mean, you know, I mean,
No, the problem is that I wanna go to Austria this summer because I go to Austria every summer and it's different. Yeah, it's a different one. So, but actually, yeah, this is okay. You need to check the prices because it's just hilarious. Like, look at the prices; it says so much. Like, just.
Hey kids, let's play a game. The game will be called Guess Which Category is for Eastern European Countries.
Which is just half or third or as much as the rest of it.
Whoa.
Okay, that is. Whoa. Whoa. That is actually just. Oh my god. That is actually not much. That isn't much more expensive than the than a two-way ticket. Like it's like instead of just buying a return ticket, it's not much more expensive than a return ticket, and I can use it like anywhere as much as I want. This is a good this is a hell of a good deal, and this is the without a without discount. Like I can't see the student discount though, but like yeah, where's the student discount though? Is there even a student discount for this? But this is a like this is a good deal. Oh yeah. Yeah, and there's a 25% discount for and this just